And here we are. Welcome everybody to the first Cloud Native Computing Switzerland Meetup of 2021. It is 4 p.m. in Central Europe time. We are Thursday, February the 18th, 2021. Thanks to all of you who are joining wherever you are. And of course, thanks to our speakers. We are going to have a great session tonight, very interesting new technologies and new things we're going to learn from them. Very quickly, you two who are participating as attendees to this session, if you would like to present your own technology, your own ways of working, your ways of using cloud native technologies, please contact us. We will be very happy to have you on board. Just the same way we have today these three amazing speakers who have contacted us spontaneously with these ideas for this talk. So thanks very much to them. Very quickly, the agenda for today. We're going to start with a presentation by Dennis Zimmer about running a trusted and tamper-proof CI/CD pipeline from code to runtime using CodeNotary. Then we will learn about Open Policy Agent and the evolution of access control with Anders Eknert of Stira. And finally, we are going to learn a little bit about managing multi-cluster configurations baselines with GitOps continuous delivery by Jan Bruder of SUSE, Germany. And we are going to end up around 6 p.m. as usual. Just a few words. If you cannot attend or for some reason you have to drop out during the presentation, don't worry. We are going to upload this very video tomorrow to our YouTube channel, vision.tv. So feel free to connect to it, subscribe, and be notified of these upcoming videos and all the others. We publish new content every week. Remember that this presentation we have a code of conduct. We never had problems so far, but we always remember everybody to be respectful, and it's usually the case. So basically, there's nothing to fear about that. And also, very important in terms of your interaction with the speakers. So we have a Q&A box for those of you who like to type. Feel free to use it. We are going to be moderating. There's Marcus. My colleague Marcus, he's in the audience as well. He will be helping me as well, moderating the questions and so on. And if you would like to ask a question openly to the speakers, feel free to raise your hand. There's a raise your hand feature on your Zoom client. Feel free to use it. We are going to then give you the possibility of asking this question to the speakers. Please be mindful of the fact that every speaker has a fixed slot of 40 minutes. So, and this includes the Q&A. So we might have to cut short the answer, or maybe even, unfortunately, not be able to give you the possibility to ask the question because of timing. So I hope you will understand. Excellent. So basically, that's everything from my side. So I'm just going to make sure that my colleague Marcus is as well a panelist. I'm just going to promote him. There we go. Marcus Speth, he's the CMO and CEO, co-CEO of Vision as well. He joins me tonight on stage to welcome the speakers. So that is everything I had to say for the moment. So I will give the stage to Dennis Zimmer from CodeNotary. He will speak, he will talk about how to run a trusted and tamper-proof CI/CD pipeline. So Dennis, the stage is yours.
Thank you very much, Adrian, and thanks for having me. What I want to cover today is something that actually was also in the news a couple of weeks ago. So whenever a CI/CD pipeline is compromised, you can end up in a very bad situation, not just yourself, but when your application, your software is being distributed to other companies and other companies are working with your applications, they might end up in a very bad situation as well. And so SolarWinds hack was probably the most prominent one that came to light in the last couple of maybe even years. And I want to give you in this presentation also a demo. So it's not just about walking through some slides and having some questions in the end. For me, it's extremely important that you also get a look and feel what we can provide to you. And one very important thing is we offer something commercial, but we also have plenty of free applications you can use. So there's not always dollar amounts involved. So when Moshe and I started the company CodeNotary, we wanted to solve a problem that everyone faced at one time or one way or the other, because in the physical world we actually are used to that things that occurred cannot really be undone. So if you have a car crash, typically even if you do your best to fix it, some expert will find out about this car crash, and the car is just losing value if you like it or not. And the funny part is in the digital world, we are also used to that this is not the case. And sometimes you don't think about it. Sometimes you are even a victim of one of the hacks that happened. But something that is very common is that your database, for example, only stores the last value. So you don't even have an idea about the history of the data inside of the database, or what was the date before, the value before, the entry before. And you need to put some effort, and a lot of effort, at least to have this data in an archive solution, somewhere where you can restore it. But then, of course, before you are going to restore it and do some forensic actions, you need to be aware that something bad happened. And we have plenty of different customers and use cases. Some of them are I would say, pretty massive from a financial impact. But I give you one example. It's about gambling machines. So when there is actually, you have an online account and you maybe win some money, and at some point in time, typically every week or every 2 weeks, money is being transferred to your account. If somebody could tamper and change the bank account details of your record, he would receive the money. You would notice probably a week or two later, but then already somebody needs to do forensics, and maybe the guy already, and the DBA typically, maybe changed the value back to the original value. So it's really a lot of impact and a lot of work involved if you want to get the real value that was there at a given point in time. And we wanted to provide a solution that exactly tackles this issue. So immutability, but also having an immutable history of everything that has ever written to a certain key, to a certain value, so that you always can go back in time and also have a kind of data lineage. So what was the case in different databases, in different systems at the same time frame or in a given time frame. And I already mentioned some of these attacks were also in the meantime very, very comprehensive and very professional. So SolarWinds, it's definitely not a hack where you can say, oh, 2-3 people should have done something different and then this hack never happened. It's actually a very, very comprehensive hack, but nevertheless, it shows that the trust in a brand name, the trust in digital certificates, and basically the software was legitimized by having a digital certificate signature, is not enough. You actually need to do your own trust, or you add your own trust to any digital asset and artifact that you produce. And therefore, we're focusing in this session about the DevOps pipeline. And I have an example using GitLab in a pipeline scenario, but you can use pretty much everything you like. And the solution we built is called ImmuDB. And ImmuDB is a database where everything is stored automatically immutable. So there is a hash tree attached to every data that you write. And this hash tree is automatically statically linked to your data. So whenever something would change, you would immediately be detected by every client that also has the state of this view as a Merkle tree, of this Merkle tree. So there's always a way to audit, but also a way to detect any changes inside of a database that might happen in hindsight physically, or because of the history. So for example, take ransomware as an example. If a ransomware would have access to your database and would just encrypt the value, so read the value, encrypt the value, write it back to the database, you need to have a backup restored to get back to the original value. If you don't have a backup, then you're really deep in trouble. In IMDb case, the encrypted value would be the last value, but you would just need to go in the history one level back or one item back, and then you see the real value again. So there's never a change that overwrites any value inside of this database. But we also wanted to have something very fast. So of course, a lot of people already are in big technology trends like blockchains, DLT, and so on. But what we wanted to achieve is something that runs on premise or in the cloud, so you can choose. It's easy to set up. It's extremely fast. So you don't have a limitation of 20,000 transactions a minute or something like this, because then you automatically need to choose what kind of data I'm going to store in this database. And in a CI/CD case, maybe you create hundreds, thousands, or even millions of artifacts a day. So depending on your job and depending on your automation grade, it can easily become an obstacle and a big issue for something that is too slow to handle all this storage. And then you need to choose what to store, and you need to also to choose how long you store data and how important the data is to be immutable or not. In our case, you don't need to think about classifying data. You just write to IMDb and it's automatically stored immutable. And it runs embedded, so you can embed it either in your own application because it's an open source on Apache 2, or we also have binaries and you can compile it to run on an ARM, like a Raspberry Pi or even a RISC-V. So it's also ready for IoT cases. In the meantime, we also have a real community that is very actively also working with us on improving IMDb. We have really focused on performance, so not just ease of install and ease of setup and running it. For us, it's also extremely important that you can really reach a great throughput. Of course, these 10 million writes a second you don't get on a laptop, but on a laptop you even get to 1 million writes a second. And in the presentation, you also see the links where you can find it on GitHub. So coming to the use case of a trusted DevOps, when we thought about immutable data and immutable data in combination with a pipeline, the important part is that the identities are immutable. So you cannot, when you go step by step, your developer identity cannot just be replaced by somebody else's identity. And there needs to be a kind of a trust level. And the whole action that takes place, we call notarization and authentication. And the goal is, when you look at the pipeline from left to right, from code to build to deploy to distribution or runtime, everything that comes in is being authenticated, and you can create all kinds of conditions if something is allowed to be put or calculated and used in your pipeline. And everything that goes out of each step is being notarized with the identity of the machine or the person that is responsible for this step. And compared to digital certificates, we never touch anything. And we also don't replace anything. And when you think of typical digital certificates, every step would basically replace the certificate of the step before. And when everything ran through a normal workflow, the final notarization or the final digital certificate signature would be the only one that you can see afterwards. And that is a huge issue, because think about the following. Inside of your CI/CD process, you have a cluster of vulnerability checkers. 4 vulnerability checkers, and one is out of date for 1 week. How do you find out after months which of the artifacts and which of the current binaries you're running in your production environment was scanned by an outdated vulnerability checker. If you use the solution and the technology that I'm going to show you, you could just query for the identity of the outdated vulnerability checker and the time frame, and then you see what artifacts and what binaries have been touched and scanned by this vulnerability scanner during this time frame from, let's say, Monday to Wednesday. So let me give you two intros into the application itself, because somewhere you need to notarize and authenticate assets. So there needs to be somewhere a system or a platform where everything is being stored. And that is on the basis of IMDb. So we have CodeNotary Ledger Compliance. You can deploy it as a virtual appliance, or it's also available as an installer for Linux. And when you set it up, it runs for you the IMDbs, and every ledger is basically IMDb database. Or we also have a timestamping service that you can use for free, and it's always online. And this CodeNotary Ledger Compliance setup, you can also run with one ledger for free, so you don't have any additional costs. I have already deployed the system here. And what I'm going to do first is creating a new ledger. Creating a new ledger means I'm going to create a database that only contains the data, for example, from this use case, my DevOps use case that I'm going to follow now. I can do some, put in some labels. And then I create an identity. And I get an API key back. So this API key is now connected to an identity, and I'm going to copy this one, and I can create as many identities as I like. So I could create one for my GitLab engine. I could create for my 4 vulnerability checkers. Each of one gets one API key. That way I can differentiate, and I could, of course, put all these API keys into secrets, either in a GitLab store, but also when I use different CI/CDs, I could also use a HashiCorp Vault. All these secret stores I could use to protect the API keys as well. And then I'm going into my Linux system here. So what I need to do is I just need to make sure that my system is aware of this API key. So what I'm going to do is I'm going to quickly set my environment variable, and then I'm going to log in. And I'm going to log in to the system here, so the 0109, with a VCN command. The VCN command line, I also have the URL in the slides, is a command line interface where you interact out of your application, in this case, the command line, but later on we are going to use it also in the pipeline recipe itself. So now I'm logged in, and now I can use VCN to do notarizations or authentications. So let's just go here, VCN, and then I notarize something. Let's say I notarize this file here. So this file, the SHA-256 hash is being calculated and sent to Ledger Compliance as a platform, or whatever platform we want to use, the timestamp platform, or we also have a public platform that is really publicly available. So you could also leverage and work across companies. So we have a software company as a customer, and all software they produce should be authentication, or every vendor and every customer of them should be able to verify or authenticate every asset they produce. And that way they need to have a public endpoint. So VCN is also capable of connecting to a public endpoint. And now I trusted this asset. So when I would change it, let's go here, and I'm going to add something here. And I do a VCNA. It tells me, okay, this was not notarized. It's not the correct file. If I'm notarizing it, of course, it comes back and says, okay, now it's trusted. But before it was unknown to the system. change it again. And of course, with every change, I need to notarize it again. And that way, whenever something happens and somebody changes it, it automatically needs to be notarized again. And that way, you can make sure that nothing is really being changed or tempered, because the platform is also tamper-proof. So you have a protection. First of all, you have your identity with the API key, and it's being stored on an immutable platform. Everything I'm writing there cannot be changed without being noticed anymore, without being noticed. And I can also change the state. So I'm not limited to the certificate is active or expired. I can also untrust it. So untrust, and then let's do the same. Or I can also unsupport it. So untrust is really meant like a revoke. Sorry, like a revoke. And unsupport is meant as outdated. So for example, I have a new version. So then I'm outdating every older version, and only the last version I'm going to trust. And of course, I can check the history, everything that happened with this file. And I can either use my own identity, or I can also use others' identities. And therefore, the signer ID is so important. So this is my signer ID now. If there's another user, I can use the signer ID of the other user to verify what is the status that the other user or the other machine gave to this asset. And we're going to see it in the recipes after this demo here. And I mentioned this timestamping service. So if you go to timestamp.codenotary.com, you can just register here with your email address or with multiple email addresses, and you get different API keys. And when you have the API key, you can just start either a Docker container or do a VCN with this binary. And let's just go in here. So this actually starts now a Docker container with VCN. And then you can just log in to timestamp.codenotary.com. That's what I'm going to do here. So now I'm logged into the central appliance, and then I can do the same here. So I could also do something like this. So in this way, I could also have a notarization of my configurations of different systems, and I always verify. For example, I could even have that in my Bash RC or my C Shell RC, that I'm automatically checking if anything changed. So it's a little bit like a tripwire, but in a simpler way. So what we did here is looking at the ledger compliance. So it's a browser-based management, but you have a command line interface. You could also use SDKs and APIs to notarize, authenticate assets, or really write real data into the ledger compliance database, where the MDDB is the core of it. And you can see the history, and then the timestamping service is something that you could use even now while watching this session here. And you can find the link here. And as I mentioned, one ledger limit. So the free edition runs forever, and you have one ledger limit. But that is for this use case would even work and would be enough. And this is a VCN command line I used. You find it for macOS, Linux, Windows, S390. So it's a Go application. So you can pretty much also compile it on every system where Go compiles. And this is a free timestamping service also with the URL. And our friends from Traffic, we actually used also the reverse proxy to throttle it a bit so that nobody is shooting down this timestamping service. And what I want to show you now is how can we integrate these services into a pipeline. So what I want to achieve here is inside of one project, and I'm going to use this timestamping service to protect and to make sure that nothing has been tampered while I'm producing content. So I'm here in this GitHub project, And actually, if it's too small, just let me know, then I can zoom in. So what happens here are different stages. And the first stage is nothing else than downloading the VCN command line client. Then I'm calculating the SHA-256 checksum. And I'm using this checksum actually to make sure that the VCN binary that I downloaded has not been tampered. So nobody actually put in malicious code or something like this. So what I'm using here is the company, so VChain US is also CodeNotary, and the VChain part is on the VChain US repository organization. So I'm checking if everything I'm downloading here is really coming from this vendor. And then I'm authenticating the GitHub project. And what happens here is I'm using VCN authenticate, and then I put in a type in front. And VCN cannot just authenticate notarized files. It can also be used for Git repositories, for Docker images, for folder, and also Podman. If you have Podman images, you just need to put that in front with a // and then you point to either the directory, the file, or whatever. I'm writing this into an HTML file that I'm going to add to my container afterwards. Then I'm logging in. These passwords and the API key I have in the secrets of GitLab. And only if this works, I'm really moving forward. And then I'm notarizing everything that is being produced. So I'm also notarizing, for example, the VCN command that I'm using. Then I'm changing the user. So before I was using the CodeNotary user, now I'm changing to the CodeNotary GitLab user. And that is exactly what you can do to really differentiate inside of the stages between different users. So in the end, what you get is kind of a bill of material of everything that came out of your pipeline, and every step has been authenticated and notarized. And in this case, it's authenticated against the Git repository is authenticated if it's known. And of course, you could also authenticate against a certain identifier, so a certain signer ID. So only if you're QA member, or only if your site engineer has notarized this GitHub repository, it's going to run through all the different steps. The next step is the building step. I'm doing the same just for security reasons. I'm downloading the file again. I'm checking if it's still a good file that I can trust. And here I'm authenticating against a signer. So only if this part here worked, this part is going to work as well, because the notarization happened from the build before. Then I'm building the container. And here I'm notarizing the container image with attributes. So in this case, I'm using the GitLab information. So I know exactly this container image came out of the following GitLab project and GitLab build. And then I'm using a different user again for the notarization. And I'm more than happy to share also all these recipes with you. I'm not sure if there's a good place to share afterwards, or you can just reach out by email. And I'm more than happy to share it with you. And here I have a vulnerability scanner. And also this vulnerability scanner, if nothing is being found, it runs through. But for example, if there is a critical package, I'm going to unsupport it. So I can also check for the status, an unsupported status afterwards, based on the result of the vulnerability scanner. And only if everything ran through, I'm going to push it to the Docker Hub in this case. And I have another script that also publishes it to a Kubernetes environment. So if we check it here, so I'm going to change something here. So then it's automatically being triggered. This is, of course, Murphy's Law, because, yeah, okay, because I really notarized it some minutes ago. No, actually, sorry, I'm in the wrong project. So now I tricked myself. Let's go into this one, because here I'm really notarizing publicly and not on the ledger compliance instance. So if I'm making a change here, but the recipe is the same, it's just notarizing publicly. So now the build is triggered. And of course, this changed the idea here. Somebody just changed some code, or somebody just changed the recipe, and it's not notarized. So it's not notarized by somebody who can approve it. So the whole recipe is failing. Now I'm going to notarize it. And this is like here. So I'm going to log in. And then I'm changing it here. I need to, of course, to pull it. And then I'm notarizing it. So now, as it has been notarized, this should run through. So now I can retry again. So and what happens now is VCN is now checking if the correct person has notarized the Git repository. Before it was not the case. Now it is the case. And now it's going to pass. And it's going to run through the different pipelines. And of course, now one of the questions would be, but if my developer has access to the GitHub repository, he could just remove this part from the, what is this? This part from the, yep, I know what it is. So I used the wrong user to notarize. Give me 1 second. Because you see here the status is unknown. Oh, okay, sorry. This is here the fact. This is always Murphy when you actually show something live. It worked, but given the short amount of time, I'm just showing you. So it actually went through yesterday, and it passed and it deployed. So from a step-by-step perspective, it went through, then it built everything. So here the scan also happened. And here you see that the assets have been then notarized, in this case, then by the vulnerability checker. And one thing that I want to show you additionally is, I just mentioned that somebody could, of course, say the developer changed the recipe because he has access to the repository. So he could just change the recipe as well, remove all the authentication and the notarization. Therefore, what we recommend is either that there's another one another job that just checks for the recipe, and if the recipe can be authenticated, or that you have a separate project that basically triggers another project. And you have different permissions. So you only allow a secure run, or this part can only be accessed by, let's say, the CIO or the reliability engineer, the software lead, whoever. And every change needs to be notarized here. But this part is accessing the other project. So in this case, it's going to the other project. So it doesn't matter. If a developer would change the recipe here, it wouldn't matter, because the real project or the real recipe is running in a separate project. So that way you can also protect that somebody would change the recipe who has access to the source code. And the last thing I want to show you, because it has been deployed now to a Kubernetes environment. Let's check if that is the case. Yeah, so it was deployed to a Kubernetes environment. And what I'm going to do here is so I'm just doing a kube CTL kube kuttle forward. And this is the application that has been deployed, and it has been notarized. And I can actually check here. So this is just a stupid, simple web service. But here you could see the result that has been notarized. So this is basically the container and all the information. And here you could create a dashboard where you see what is running in your environment. And we use a project that is called CodeNotary. And CodeNotary is able to check your runtime, what container images are verifiable and which are not verifiable. And that way, of course, you could also create alerts. So the moment something has been deployed that is not verifiable, that you get an alert and you can react on it. And I also explained some of the steps here. Also explained the separate project. So when you have access to the presentation afterwards, you could also double check what I presented. And this is this deployment. And you can find the project here. It's a Helm chart, or of course, there are also the normal YAML files you can deploy into your Kubernetes. And that way, you really have a full view from your source code, the authentication and notarization by every single step, to the final runtime, where you can use your normal Grafana or Prometheus installation to scrape the results and visualize an alert on these results. And one last thing is you also have everything in a dashboard. So everything that has been notarized, you could also access in a dashboard. That is especially of interest when you have really public assets. So what I mentioned, one customer or one software company is producing assets that other clients or software companies should be able to verify. So you could also point them to online verification and even provide online verification yourself. So now I'm open to any questions.
Thanks a lot, Dennis. Do we have some questions from the audience? I don't see any written, but maybe somebody would like to talk and to ask the question openly. Please raise your hand, as Zoom calls it. And we have Philip, who would like to say something. So I'm going to allow you to talk, Philip. There you go. You can ask a good question openly.
Thank you, Adrian, for unmuting me. I actually don't know how to turn my video. I don't know if it's even possible. So I will not.
I think it's not possible, but it's okay. We can hear you very clearly.
Thank you very much for the great presentation. It was very interesting. I Maybe quick intro. My name is Philip, VP Technology at Beekeeper. I am really interested in immutable data and immutable databases. The one question that I had is, how do you deal with deletions? I know that is usually the topic that you know, doesn't sit well with immutability. But if we were to use something like ImmuDB for customer data, and then we would say, okay, this action needs to be deleted.
Mhm.
How would we deal with that?
So actually a great question, and especially it's a great question that is coming pretty often in the context of GDPR. And the data deletion, of course, in our case, it's also not simple and not easy to delete anything. So what we typically recommend to customers and users is that they use different databases. For example, when you have a data classification, you know it needs to be deleted every couple of months or after 3 years, for example, that you use different databases and you just delete then the whole database. Because the deletion is, of course, a big issue. If you have an immutable system, you typically should never allow any deletion. But what we currently look into is a way that you delete data without deleting the proof. And that is something that we are working on. I can't give you a real time frame, probably 3 months to 4 months away. But that way, because we have a statically linked hash tree to the data, we could potentially delete the data and leaving a kind of an empty spot there. So basically, the data itself is deleted or encrypted or in some kind of a void state, but there's a timestamp when it has been voided or removed. But that is something that is probably 3 to 4 months away. Right now, we would really recommend you to use different databases, because the database itself, it's easy to handle hundreds or even thousands of databases with one ImmuDB instance. So you could even create a database for every tenant or every user. It would also be possible. And if this user wants to be the data deleted, for example, or all the contacts and information deleted, you could drop the whole database.
Thank you very much.
Thanks a lot, Dennis. We have time for maybe one more question. So I don't know if somebody would like to either write it or raise your hands. We still have a few minutes. Very quick question. I don't think so. I think, well, in any case, we can all see the email of Dennis at codenotary.com. Dennis Zimmer, thank you so much for this great presentation. Really, really interesting things and very, let's say, very relevant for the, you know, the current things one can read in the press in terms of security. So really, really interesting. And thank you so much for this presentation.
Thank you very much.
No problem. And we continue then with Open Policy Agent and the evolution of access control by Anders Eknert from Stira. Anders, the stage is yours.
Thank you. It's great to be here. Let me just see if I can hide all these annoying windows. And can you all see my screen?
We can all see your screen, yes.
Okay, great. I'll just get started right away then. Yeah, so the topic for my talk today is the evolution of access control and identity and authorization in distributed systems. So before we start, a few words on who I am. I am Anders. I work as a developer advocate at Stira, which is the inventors of OPA. I have a pretty long background in software development and in particularly in identity systems. So for the last 2 years or so, I've been working primarily with OPA. And when I don't do that, I enjoy cooking, food, and sports or football in particular. And of course, feel free to join me for a chat on Twitter or GitHub or whatever. So okay, let's get this show started. So kind of the context here, obviously from a cloud native perspective, is obviously the microservice or the microservice environment. If we kind of start from the monolith, from an identity and access control perspective, we see all our monolith kind of built up with all these modules. And of course, moving into microservices doesn't mean that we can automatically remove the need for these modules, but they're pretty much the same. It's more or less just the way we communicate between these services. And of course, in terms of identity and access control, we're naturally most interested in authentication and authorization. So that's where we're gonna zoom in today. So if we go back to the monolith first here, and we can, how did we deal with identity here? A pretty basic model could look something like this. So the user would present his or her credentials to an app. The application would then ensure that these credentials were correct, going to the user database, and provided that the user authenticated, perhaps go to the permission database, and then go and fetch the actual data that this user asked for. So it's a pretty simple model, of course, and there's only like one app doing all of this. Though when we look at microservices and distributed application, there's been a common trend from the last like almost 10 years or so that we delegate authentication. So we let somebody else take care of that. Though for permissions and access control, this has still been the responsibility of the application. So there hasn't really been much in terms of development in that space. Okay, so now that we move into microservices or services, how would this model change? And an example of a very naive model would be kind of just move what we had before and just move it into managed services. That would be like, it would be a very simple transition, but it wouldn't be a very nice one. As you can see here, we're still passing around these credentials along with all requests between these services. And since these credentials, they don't really carry any data, so all our services need to go to this user database to authenticate the user, and they need to go to the permission database to authorize the user. So there's a whole bunch of requests here, and it's obviously not very performant. So just to start identifying some problems here, it's obviously first, it's the credentials. We'd rather not deal with passing around passwords among all our services. It's not good for any reasons really. And the other problem here is all these lookups. If we for each service need to go and ask who is this user, then it won't really scale. The more services we add, the slower it's just going to be. And of course, not to mention all the load that we're going to put on this poor user database. So what we can do here, of course, is we introduce an identity system. And this is, of course, what we kind of talked about before in terms of delegation. We, rather than sending around these credentials, we have the user just send her credentials to the identity system. And only the identity system would actually talk to this user database. And in return, we'd get some form of token that we can then use for as a kind of a claim of our identity. So that's what we'd send around in these services. And just by doing this, we kind of cut out half of all these requests. So that's a huge improvement just right there. And of course, not only humans have the need to access for our services, but there's all these devices. There are cron jobs, internal services, IoT devices, and so on. And so if you take all these into account, then you pretty much got OAuth. So what OAuth really does, it defines a set of flows for a user or for any type of client to obtain these tokens and then use them as their credentials. And OAuth itself doesn't really say what the token is or what it should look like. And despite being called an authorization framework, OAuth doesn't really deal much with it in terms of authorization, but it's rather more about delegation. There are some kind of primitive means for doing like fundamental access control, like scopes and audiences and so on. But it's really not an authorization framework. And of course, many of you have integrated or interacted with OAuth in some means. I think the most common integration is probably these social logins, like login with Facebook, login with Google, or whatnot. OAuth doesn't really say much about what a token is, and it doesn't say much about who a human is, or what we can expect from in terms of data or structure of that data. So OpenID Connect adds an identity layer on top of OAuth, and it introduces concepts like ID token and user info endpoint so that we can kind of get to know more about the identity of the user. And again, OAuth introduced scopes, and OpenID Connect kind of extended on that and said that certain scopes should map to certain claims. So if you ask for the email scope, you should get the user's email address as part of the token, as part of the claims. So yeah, we have a pretty good model here. We have OpenID or OAuth, and we have OpenID Connect. So still, we haven't really figured out what these tokens are. OAuth doesn't say. OpenID Connect does say what an ID token is, but not much more than that. So how would an IoT device identify itself, since they're not really covered by OpenID Connect? And still, if we're dealing with all these kind of opaque tokens, our services wouldn't really know what is this token. It's just some random string like ABC 1 through 3. It doesn't really mean much to me. So if we are to deal with these opaque tokens, we'd still need to go back to this identity system, and we'd need to ask who is behind this token, or is it even a valid one? So obviously, as you can see, now we're kind of back to where we started. This was the problem, where we were calling this user database in each service. So no, that's not really what we want. And to help alleviate that, JSON Web Tokens came along. And what a JSON Web Token is essentially a self-contained collection of claims, which is signed by the identity system. So we can just verify the signature, and we can know that, okay, these claims are, if not true, then at least claimed to be true by the identity system. So we have somebody backing these claims. And the big benefit of this is that we don't need to go and do these extra lookups. As long as the claim is verified, or the token is verified, we can just grab the claims from the token, and we don't need to go anywhere else. So there's no extra overhead in using these claims. And as another benefit, these JOTs are immutable. So there's no way you can kind of tamper with the contents or change something or any data in it without breaking the signature. And of course, JOTs are virtually everywhere. There's libraries for pretty much all languages and platforms, so they're very easy to work with. There's a little caveat here that we might want to mention, though, because again, the benefit of these JOTs could also be a problem, since anyone can read what's in there. It's not just our services that don't need to go to the identity system, but our users, they don't need to go there either. They can just decode this JOT and have a look at what's in there. And of course, this could be sensitive data. It could be things like email addresses or phone numbers. And even if it's just your email address or phone number, it might not be something you expect to see there. And it also could create unknown couplings, because if you hand this out to users, it will mean that they could start and build integrations. Maybe your user has a mobile app where they want to present the name of the user when the user have logged in. So it says like, hello, Anders, and welcome back. And which means if you later on decide to change the name or the structure of your jobs, you're going to break this application, and you had no idea, because how could you? You can't really control what happens once this data leaves your organization. So so if you can avoid it, don't ever send out JSON Web Tokens outside of your organization. And there's a few possible mitigations here. You could use opaque tokens on the outside, and then have them exchanged for something like jobs on the boundary. So once it passes the gateway or wherever, you take that opaque token that you gave to the user and you exchange it for a job, and then you use that internally. So you kind of get the best of both worlds. And another thing you can do, of course, if you still want to use or need to use JOTs outside, is of course just to limit what's in there. And there's also this option of using encrypted JOTs, which is kind of something in between an opaque token and a normally signed JOT, because it's not readable by anyone. But on the other hand, it requires kind of this whole decryption infrastructure in your services. So it adds quite a lot in terms of complexity. Okay, so we've come a long way here already in our evolution of identity. So we're now sending around these JOTs instead, and there's no longer a need to call the identity system in our services. Of course, we still have all these arrows. So how do we know that, even if we know who the user is, how do we know and how do we enforce that they're allowed to do this action that they're trying to do? And there's a few ways we could kind of start to remove these arrows. And a very common one is this gateway model, where you kind of, or you could call it the firewall model as well, if you wish, where you kind of say that whenever something enters the building or enters the perimeters here of our systems, we're going to make that kind of authorization check. So we're gonna check, is the user allowed to do this? And we only make one call to the permission database. And if they pass that, then it's like it's an open highway. They can just the services following that is not going to check anything. And obviously, this is we want a lot here in terms of performance, because now there's only one lookup. But there's a few problems associated with this model as well, as I'm sure you can all identify. Like, what if there's any way that you can pass the gateway, there's essentially not going to be any authorization checks. And also you might want to have services and cron jobs and things running inside your cluster, and now there's not going to be any authorization of their actions either, or they need to somehow go through the gateway and kind of act like an external user. So some problems with that too. So another way of doing it could be to actually move that to the absolute backend or to the data layer, because in most organizations, it's the data that you're actually trying to protect in the first place. So it kind of makes sense that you move your authorization checks there. And this model it has the same performance characteristic as the gateway model. There's only one lookup, but it has the added benefit of even if there's a breach here in, I don't know, service number 3 here, they still can't access your data. They need to actually breach the service protecting this data. So yeah, it's in terms of security, I think it's a better model, but it's not really one we see a lot of. And a problem, of course, with moving all the responsibility back to your data services, they were, or in the microservice architecture, they were kind of meant to just work with data. And now you're starting to move a whole bunch of logic in there. So now you're kind of reinventing the monolith. And that was kind of the whole point of moving away from. So yeah, that's not going to fly either. What does fly then? Well, that would be OPA. And what is OPA? OPA is an open source general purpose policy engine. It means you can use it for authorization, and it's a common use case, but it's not in any way limited to just that. What OPA does, it decouples policy, meaning kind of what the rules you have in any system from your business logic or application logic. So all these kind of if and else clauses you might have in code, where you check for the identity of the user, or whether they're in the right group, or they have some particular role. We move that out from applications, just kind of like OAuth and OpenID Connect moved identity out of applications. That's how Open Policy Agent works with authorization. So we decouple policy from business logic. We don't do enforcement though. That's still up to your application. So OPA is kind of like an oracle. You ask it some question, and based on the policy you configured, you're going to get the response back. So you might ask, I'm Anders, and I am in these or those groups. Am I allowed to read the user's endpoint, or am I allowed to modify a user? And OPA is just going to say yes or no, or maybe no because you're not an admin or something like that. But OPA itself is not going to enforce anything. It's not going to call the police, or it's not going to respond with like a denied or a 401 or 403 like forbidden, because that's still up to your app how you actually enforce that decision. So OPA does or makes the decision, but it's still up to you to act on it. And what OPA really provides us is a unified way of doing this. So we have one system and one policy language to deal with this across the stack. So no matter if you're writing services in Clojure, in Java, in .NET or Go, you have one way of dealing with policy, and you have one way of dealing with authorization. And these policies, they're written in a language, a declarative language called Rego. And we see use cases ranging from anything around like admission control in Kubernetes, obviously microservice authorization, but could also be for filtering data depending on some policy, CI/CD pipeline policies, and so much more. Again, it's a general purpose policy engine. So it's while the topic here is access control, it can certainly be used for so much more than that. And OPA is an open source project again, and we have a very active and vibrant community. I think these pictures are a few months old. I think we're almost 4,000 in the OPA Slack now. And I think we're listing like 50 or 60 integrations, meaning like open source projects where people have integrated OPA with some system or with some programming language, and they contributed back their projects to, or at least published their project somewhere. So no matter kind of what platform or language you're using, chances are pretty good that there's already an existing integration that you can use. Okay, so instead of the gateway model or moving data checks here, where do we do authorization? Well, we want to do it everywhere. That's what's the whole point. We don't want to have these kind of, if you come into the gateway, we're going to check there, or we're going to check like in the data layer. But ideally, we'd want to check everywhere if you're allowed to do something or not. And that's what OPA does. It injects itself alongside your services, and it works kind of, again, like this Oracle, where you ask a question and you get something in response. And OPA runs just as close to your services as possible. So if we kind of zoom in here, we can see that OPA is a self-contained little binary. And normally, if you're in a Kubernetes environment, this means you're going to run it as a sidecar. So it's going to run on the same host, and you're going to query it kind of just as you'd query any app running on your local computer. So it's just localhost pretty much. So it's as fast as it possibly can get. And applications would normally communicate with OPA through OPA's REST API. So that's how you query it, like, and ask these questions to OPA. And there's also a Go library if you're writing Go applications. And for more kind of other use cases, there's also an integration with Envoy or Istio if you're using service mesh technologies. And the more kind of esoteric use case is probably WebAssembly, where you compile your policies to machine code, and by doing that, you can run them anywhere where you can run WebAssembly. Okay, so that's deployment of OPA, and now policies. What about them? What do they look like? Policies are written in a language called Rego. Again, it's a declarative language, so it's kind of like SQL. Rather than saying what or how you want something done, you just say that you want it done or what you want done. And the policy engine will then kind of optimize and restructure that in the background. You don't need to worry too much about the details. And a policy is pretty much, it's a number of rules or a collection of rules. And a rule, normally, it returns something like true or false. So are you allowed or not? But it could also return any complex data structure you might like, as a JSON object, strings, lists, and so on. A pretty common pattern is, of course, if you deny someone in an authorization system, for example, you might want to tell them why, because you expected them to have a certain role or so on, so that they can actually act on it and maybe go tell their supervisor to have them added in the right group or so. And there's a test runner or test framework provided with Rego, so it's super easy to test your policies in isolation, which is, so any kind of these best practices around working with tests and kind of pull request, code review, and so on. They apply just as much to Rego as any other language. And it's a well-documented project or a well-documented language. And yeah, so let's have a quick little demo here of what Rego might look like in practice. So it's not just theory. So for this demo, I'm going to use the Rego Playground, which is a super simple way of testing Rego without having to download anything. But you can just offer your policies here, and you can try them out with different inputs, and you can directly evaluate your policy to see what the outcome is. So I'm just gonna, for 5 minutes, I'm gonna write a super simple policy. And again, a policy is a set of rules, and we're gonna add a rule called allow. And first of all, we're gonna say that by default, the allow rule is going to be false, which seems like a pretty good default. If you don't provide any input, or if there's no data to work on, we just say like, no, you're not allowed. And now let's extend on that rule. And the kind of anatomy of a rule is something like this. You have the rule head or the rule name here, which is allow, and then followed by a body. And if all the statements or expressions in the body is equal to true, then the rule is going to be true as well. So if we say 1 equals 1 here, and we evaluate, we're going to see that, yeah, allow is true because this is true. And any conditions in the body are ANDed together. So if you say, if you add some more conditions, they all need to be true in order for this to be true. So if I change something here, I see that allow is no longer true. So that's super simple how rules work. Of course, this isn't really useful though. So let's add something interesting. Remember here when I said that the way it works is you ask questions and then you get something back from OPA. You get the decision back or a response. So I'm going to offer a question here, and these questions are just JSON like anything else. So a normal question might include the path or maybe the method. So we say like somebody is trying to make a GET request at the path, and we're going to say users. And we can say here, let's change our policy here. And we can just say that if the input path is, let's call this public path. And it's an array, so we're just going to take the first part there, and we don't really care what follows behind that. If that's public, and the method here is get, meaning if someone is trying to read on this public endpoint, they will be allowed, or they should be allowed. And we can see that OPA says, yes, they are allowed. So now we have a first rule. It's a very simple rule, but it just means that if anybody can read from the public endpoint. And since that's what we were asking here, we are allowed. So let's save that rule and move on. Let's add something more advanced. And the way we do that normally is we just add another one. It could be, and this, it has the same name. And this will mean that if any of these allow rules equal to true, then allow is going to be true. So it's kind of like or. As you might remember, inside of the rules, we say and. All of them have to be true. But outside of the rules, just one of them have to be true. So it's either and or it's or. And in this case, we're going to say like if the input method is put, so somebody is trying to change something here, and the input path, is users. So somebody is trying to change a user. Then we're going to require that the input, and let's create a user object here as well. So we'll say user, we're going to say username. There's. And we're going to change the path here. So somebody is trying to, so Anders is actually trying to put, that was what we wanted. So he's trying to change, I'm trying to change my details here. And the other path component here is probably the name of the user. So I'm trying to change the details of user Jane. And what we want to allow here is that anyone should be able to change their own details, but you shouldn't be able to change details on another user. That kind of makes sense. So the way we could describe this here is that if the input username is equal, or sorry, if we say that input path, the next component, which would be the name here, if that's equal to the username, then we should allow it, because we do want people to be able to edit their own details. In this case, we see that I'm not allowed because I'm trying to change the details of Jane. If I do change this to my own name, we should see that now I'm allowed. So this is a 5-minute version of working with Rego policies. There's some learning curve. It's a new language to learn, but since it's all kind of JSON data, and you work with these assertions. After a couple of hours, you're going to feel fairly confident, and a few days, I'd say, for really getting to know and learn Rego. Okay, so that was a short demo. So what about these permissions? When you're working with data, you obviously you have a lot of policies, but you still want to connect external data. And we already talked about JSON and JSON Web Tokens. That's one obvious way of an obvious data source. If you're still sending around these web tokens, just have OPA use them and take the data from there. Other data can be provided as part of your input. There's a bundle API for kind of packaging data from some external source and have that served to OPA. And you can also push data into OPA. And as your last kind of option, you can even use an HTTP client inside your policies to reach out and to grab data at policy evaluation time. So that's policies and permissions. And this bundle server then kind of, through the use of OPA's management APIs, kind of ties this all together. So all of these OPAs deployed in your cluster, they're going to report back on any decisions they took and send it back to the bundle server, if you so wish, of course. And they can also optionally report back on their status, and they can also go to this bundle server to pull configuration periodically. So now we're back to drawing these arrows to some centralized component. But luckily, this is all a synchronous call. So there's really no communication that's blocking here. So there's nothing that's kind of making this bundle server a bottleneck. So that's kind of the OPA model of working with authorization or working with policy. And once you have that, why stop there? Again, OPA is a general purpose policy engine. So the same way you'd write policies for your microservices is the same way you'd write them for your Kubernetes deployments or your Docker files. Or even your infrastructure. You might just as well want to have policies that would dictate the number of replicas you can have, or the number of instances you can have of a certain class, or so on and so forth. So it's truly one way of, and a unified way of dealing with policies throughout your whole cloud native stack. And with that, you're pretty much done. So where do we start now? How do you start? I suggest you start small. So kind of do what we did here when we tried this out. Maybe just open a playground, check the documentation, and start writing like a few simple policies and maybe a few tests to go with it. Check out the OPA docs. They're a great resource when you start learning. I think they're one of the better documented open source projects out there. And then, of course, once you kind of get past that, then you might want to start looking into the applications that you have already. Like start to consider like what are the actual policies we have here, because any application is going to have a bunch of policies in them. It just might just be that you never thought about it in that way before, and then you can kind of start to move some of that into OPA and delegate some of that responsibility. But again, you don't need to rewrite your whole app. Just maybe start with a single endpoint and say, on this endpoint, I'm going to ask OPA for decisions instead. And then when you see that that's working and that's a good way of doing things, then you can kind of move from there. So again, start small. And once you reach that, then you can start to scale up. Maybe look into these management APIs for after you have this running for a while, you're gonna want to have this kind of knowing what really goes on in your cluster. You're gonna want to be able to follow up on any decisions taken, and maybe have a centralized place where you can kind of manage your policies and so on. The Styra Academy is a great way to learn Rego or to learn about OPA as well. So I can heartily recommend that. And of course, join us in the OPA Slack community. There's already 4,000 people there, and there's just so many good discussions there. So it's a good way to ask questions, but also to see what problems or what interesting things others are working on. So that's all from me. So thank you.
Thanks to you, Anders. It was a terrific presentation, really, really good. I myself, I'm very curious about OPA, so it was a great introduction. Thank you so much. And
Cool.
we've got 2 questions so far. We've got one by anonymous attendee. How does OPA deal with tree structured resources and reporting use cases? For example, when we need to take all the users, for example, and want to filter them only to those whose current user have permissions.
Right. Yeah. So there's a lot of ways you can deal with questions like that or decisions like that. And I think for any like fairly complex integrations, that's where you're going to spend most of your time, kind of forming and considering like the structure of your data and how would you integrate this with OPA. And in particular, since most organizations, they're not going to start from scratch, but they're already going to have a permission database somewhere. Or so yeah, integrating with that is often like the core challenge, I'd say. And without knowing like the specifics of that data, it's hard to say. There's no like I'm just going to drop in some, this is how you do it. So I'm sorry, but I'm going to have to retort to the classical, it depends answer.
It's the classic answer, but it's a very good one. We have a second question, this one from Jonas. He says, you mentioned OPA does not take the responsibility of enforcing the decisions. Is that something that the open source integrations cover to a certain extent or to a great extent? Yeah, for sure. I think in terms of like microservices, the most common thing you can do is like if OPA says no, you're gonna just respond to, and you're gonna send like upstream 403 forbidden or 401 unauthorized, and maybe pass along like a message. But then of course there's more to enforcement, or there could be more to enforcement than that. There could be maybe you want to raise an alert somewhere because if you're working with like finance data or money, it could be interesting to do more than just respond with some error code. So yeah, OPA leaves that to the implementation. And great.
Yeah, and these kind of open source integrations, they often have some default way of dealing with that.
Excellent. Yes, absolutely. And I don't know, we still have a few minutes for one quick question, maybe one more if somebody would like to raise their hands and ask the questions directly. I will wait for a few seconds to see some signs of life on the list of attendees, but apparently not. So in that case, I will say, Anders, thanks a lot for a great introduction, terrific presentation. And yeah, and please, everybody, please contact Anders for any questions you might have about the subject. Thank you so much, Anders. And we move on to our third presentation. We're going to learn about managing multi-cluster configuration baselines with GitOps continuous delivery by Jan Bruder from SUSE, Germany. Jan?
Thanks, Adrian. Can you hear me all right?
We can hear you very, very
Thank you.
Thank you.
Having a bit of a problem here with my camera today, but I guess the important part is here, my presentation. So
absolutely, take it easy. We can see your presentation and we can hear you very clearly.
And thanks for the other two presentation, very cool presentations. So I want to talk today about the concept of managing Kubernetes security policies with Fleet, which is a relatively new GitOps tool developed by Rancher originally and now part of SUSE. Just to introduce myself, I'm Jan Bruder. I'm based in Germany, actually in Berlin since a couple of years. Before that, from the south of Germany. And I've joined SUSE recently as part of the acquisition of Rancher, which is the software developer that makes the Rancher management platform, Longhorn storage, and a number of other tools. So that's for the introduction. Why are we talking about things like GitOps and the need for a better management of security policies in cluster? The main reason is because Kubernetes is just becoming ubiquitous, and the number of Kubernetes environments and clusters is steadily rising. If we compare that to a couple of years ago, like 2-3 years ago, the typical Kubernetes environment was a monolithic, big, large enterprise cluster, probably with a couple of hundred nodes and in a shared multi-tenant environment. This is changing today, or has already changed. IT organizations embrace hybrid IT approaches, multi-cloud approaches. DevOps teams are, creating their own clusters at cloud providers because it's just becoming very easy to get Kubernetes today. And then obviously we have a lot of new use cases also outside of the traditional IT infrastructure, especially in all sorts of edge use cases like remote branch offices, industrial manufacturing. These are all use cases that also mean that the number of Kubernetes installations is steadily rising. So while previously, it was actually difficult to get a cluster working, we had to do a lot of scripting and stuff like that. That's not the case today. You have the cloud providers, basically they give you a cluster with the push of a button. You have very good Kubernetes distributions for on-prem that make it really easy to create clusters. So the focus on a management tool for Kubernetes is really focusing on the configuration management and providing a consistency. And that is not only true for functional things, but also for security things. You want to have a security baseline across all these clusters, even if they are managed in different infrastructures or even using maybe different Kubernetes distributions. And one good approach for that is GitOps. So I don't want to go too much into detail, but just to summarize what GitOps is, it's an operating model for Kubernetes management and the continuous application delivery. So you can see here the kind of a focus. Originally, it was kind of created as a continuous application delivery model. It's very closely related to infrastructure as code. So infrastructure as code was before that, and it meant describing your infrastructure with things like Terraform and version control your infrastructure to be able to very quickly rebuild and build your infrastructure. This concept is has flown into the GitOps. So it means that you put all your configuration under version control in GitOps, in Git, use it as a single source of truth for all your application environments in Kubernetes. That's not all. It also means that you're using the typical Git workflows and the primitives that the developers know, like git commit, git revert, opening and reviewing pull requests. You use these workflows to make any changes to your Kubernetes environment. That's also very important. So why is GitOps interesting to also configure security policies like OPA that we talked about previously? So first of all, Kubernetes security policies, like the workloads, are entirely managed through declarative configuration. So that qualifies them, right? So that means we can actually check them into Git and we can version control these policies. GitOps has also a nice advantage because it provides a complete audit trail for anything that has been changed, right? That's the commit log. So that is very nice from a security perspective to know what was changed, when, and by whom. GitOps also have things, Git also provides things like signed commits, so that you can use to actually prove who is the author and where is that patch coming from that changed a security configuration. And then the workflows that I already mentioned, like reviewing and approving pull requests, they also fit very nicely with the requirements for security change management, like having processes in place where SecOps are reviewing changes to permissions and things like that. Visibility is also very important, obviously, for security, and it can be a problem if you have like a highly fragmented distributed Kubernetes environment, because you're then dealing with quite low-level configuration like roles and role bindings that are somewhere stored in an API server. So having a single source of truth for all these configuration files where you can just look very quickly and see, for example, what permissions are configured here, that is also a big advantage. And then obviously one of the advantages of GitOps is that they allow you to rebuild your applications very quickly in disaster scenario. And why not use that same also for your security baseline? If you need to rebuild your production environment, you probably are concerned about the applications in the first place, but your security also needs to be rebuilt. So why don't you use that also for that? And then finally, I would say that GitOps as an operations method reduces the complexity of managing the security policies. So that means less human error and a better security posture overall. And then what's also nice about GitOps and where the difference is with things like doing Helm deployments is that it protects against configuration drift. So once when you do a deployment with Helm, once the deployment is done, it doesn't protect you against any changes that are done outside of your Helm deployment workflow. So with GitOps, you get sort of the controller model, right, where you have some kind of software process, typically an agent that is monitoring the Kubernetes API objects and comparing it with the desired state that you have declared in the Git repository. And if there's any drift, if there's any difference between that, it can alert you, or it can also automatically fix the problem. So that is also very nice from a security perspective. If you think of things like, access permissions suddenly not the way they should be. You want to be alerted to that, or you want to have that fixed automatically. So what are some of the security policies that we could manage that way? Obviously, the whole airbag subsystem in Kubernetes. So that's the access control. We define the roles with the permissions, and you're granting roles to specific users or groups with the role bindings. That is typically something that is not nice to manage manually for sure, especially in larger installations. So GitOps helps here. Network policies is another example. Pod security policies, as long as they are still being used. And then, the new policies that you can do with the open policy agent. I don't think we've seen that, but if you, for example, migrate from pod security policies to open policy agent, you will suddenly have a lot more configuration files, right? Because a pod security policy fits in a single API object, but to replicate the policies that are currently enforced with PSPs in OPA, you need to create a lot of files and version control them. So that's where GitOps really helps. And then I would also say, like, even if that's not like a classical policy object in Kubernetes, the version itself, it's also important for your security. So maybe we can also ensure that our clusters are properly patched with GitOps. We'll look at that in a moment. So what are the GitOps tools that are available? I think Argo CD, everyone probably has heard of that. Reflux is also, I think that was the first available tool. And then Rancher Fleet is a tool that came out last year. And all of them have sort of a unique approach, right? They're not really duplicating things. All of them are good and for specific use cases. Let's have a closer look at Fleet. Like what makes Fleet different from these other tools also maybe. So when Fleet was developed, the goal was really when for certain architecture decisions was really to solve the problem of managing Kubernetes configuration at scale. So Fleet was also specifically built to manage sort of the edge Kubernetes clusters of the future, right? Where you have a Kubernetes cluster running in every ATM, in every shop, even in cars, right? So where you have really hundreds of thousands of Kubernetes devices. So that was kind of the backdrop of developing Fleet, but obviously that doesn't mean that, that these decisions and the architecture that came out of it, that can't actually also be of use for more traditional use cases like managing, Kubernetes in an enterprise data center or something. Very importantly, Fleet is based on a pool-based configuration model. This is obviously for scale, right? It's much better than pushing out configuration from a single service to thousands of clusters. Another particularity is that the reconciliation, so the driving of the cluster state towards the declared state is happening on the cluster itself. So that's a bit different than, for example, I guess Argo CD, where you actually push Kubernetes objects to different clusters from a central location. And then finally, because managing a lot of clusters, you need to be able to segment them, to group them, with based on different metadata, or maybe environments. So that's also an important aspect of Fleet, to be able to target clusters based on selectors and so on, and push out specific applications to them. So this is the high-level architecture with the involved parts of Fleet. The most important components are the Fleet controller. This is the central component of Fleet, which typically runs, where all your other central services are, like, for example, the Git repository. And then in each cluster that is managed by Fleet, you have a Fleet agent running, and that is the local component that takes care of monitoring and reconciling the state. All clusters can be grouped, so you don't need to treat, individual clusters. You can push out your application to a group. That makes, that is another factor for the scalability, obviously. Fleet obviously is a Kubernetes native application. So it runs in Kubernetes. It works with an operator pattern using the Kubernetes custom resources to manage its own state. And the most important resources are sort of shown here. They are the bundles, they are the clusters and the cluster groups. So clusters, obviously, we need a way to authenticate and register the clusters that will be managed by Fleet. So we're doing that with the cluster CRD and with the cluster tokens. The bundle is the most important thing here. The bundle is basically a collection of any kind of Kubernetes configuration. So that could be Helm charts, multiple Helm charts, it could be manifests, it could be customized files, anything that you can basically deploy into a Kubernetes cluster can be in a bundle. And these bundles, the user is not building them themselves, but these bundles get built on the Fleet controller using the content of the Git repository. And then another important aspect is the configuration pool, right? So the agent will poll the state of the Fleet controller. If there's a new bundle available for this cluster group or for a particular cluster, it will pull it and will apply it. That obviously means, that's also very good for scalability. There's less network traffic, It's also very good for, you know, difficult environments where you maybe have these devices in a network constrained environment, or even on a network that isn't on 24 hours. You know, maybe you're running it on a ship which only connects once a day via satellite, right? So that's also an advantage here. This makes it a little bit more clear, again, what are maybe the difference to the other solutions. By doing this kind of fetch, config fetch via the agent, we also have a natural security boundary here, because we don't need to configure, you know, API credentials for every cluster on this left central side. That's also kind of nice from a security, but also from a manageability perspective. We only manage basically the tokens of the agents that connect to the fleet controller here. And because we are doing the reconciliation locally, that obviously also reduces the, you know, the requests and the amount of communication that needs to be happen between the left and the right side here. So let's look at the content of the Git repository. That's where we operate on. That's where we store our configuration. So as I said, Fleet supports any kind of Kubernetes configuration, from a manifest to a chart. So you can basically put everything in a Git repository. You can organize it in subdirectories. Each subdirectory will result in a dedicated bundle. Everything that is in one directory will result in one bundle. One important file that you can add to the cluster is the fleet YAML file, because this file allows you to customize configuration based on the target to which it will be deployed. So a typical example could be, you know, deploying a Helm chart across a dev and a production environment, and you need to inject different parameters, for example, different values for the database endpoints or things like that. That way you can, for example, keep the version the same, but you know, configure different parameters for the Helm chart. Yeah, at the end of the day, Fleet should really allow you to connect everything that runs Kubernetes to a central control plane, from your cloud Kubernetes clusters to data center clusters to you know, to your edge devices running on ARM. We support Fleet also for ARM64, as you can see. So if you have some edge projects running on Raspberries or something like that, you can also use Fleet. This is basically the life cycle of a bundle. So it works, you can see, quite similar if you have ever looked closely at how the Kubernetes controllers work, but it does it obviously specifically for the bundles. The outcome, so modified at the end. So at the end, it basically, when the resources are deployed, it will continually monitor for any changes. And if it detects changes, it will put the bundle in a modified state. It will also create a patch for the operator to apply in case that the operator determines that this is indeed the desired state. Otherwise, you know, you need to the operator needs to redeploy it to make sure that the state is met. In the next version, we will also make make it an option to do an automatical reconciliation, so that in case of any modifications, the desired state is applied again. So now let's have a look let's do a short demo. Before we start, I just have one cluster here registered currently on my Rancher management. So let's quickly create a new cluster. Let's just find the correct node here. So yeah, so this is the VM running just Ubuntu. There's nothing on there. I just created that on DigitalOcean, and I'm going to install K3s on this VM. All I need to do to install K3s is to run this command. It fetches a script. The script downloads a single binary and it installs a systemd unit on this machine. And as soon as that systemd unit is started, I have bootstrapped a new cluster on this machine. As you can see here, I'm also choosing a specific version. That's just so that I don't install the most recent version, and I can do an upgrade later on. So while this is happening, we also want to register that cluster to Rancher, because in our case, our fleet controller is running in Rancher already. That is just to make it easier, but you could also run fleet obviously in any Kubernetes cluster or outside of Rancher. So I'm gonna just register the cluster and call it something like this. Rancher will now generate a command for me, and this command, when executed on the cluster, it will basically just start the agent, both the Rancher agent and the fleet agent, and that's how I register the cluster to the central control plane. So at this point, you can see we can just check if Kubernetes is running on this node. Yeah, so it looks good, it's ready. So I'm now just fetching the manifest for the agent, and the agent will then be started. So we can go back here, you can see it's pending. So there's some bootstrapping happening. In a minute or so, it will be ready. In the meantime, let's have a look at the Git repository that I have prepared. So here I have sort of three directories here. The one that I'm interested in now is the policies. So we learned previously about the open policy agent and how you could use that to enforce any kind of policy in your cluster, including the security policies that you would previously enforce with PSPs. One nice example for that is to enforce the use of a specific container registry or a trusted repository, right? You want to make sure in your production clusters that you don't get any images from Docker Hub, basically. So let's have a look at this. I have created this repo. In Open Policy Agent, you always have a constraint. You always have a template, and then you have a constraint. Constraint basically maps a template to a specific environment, like a namespace, and also provides some configuration. So in this case, I've just created a constraint template that inspects the image of any pod that is launched in your cluster, and it compares it against a list of permitted repositories. That list of permitted repositories is a value or a parameter of the constraint that I also need to create. So the constraint, I have the constraint here, and you can see here I'm mapping it on the constraint template that I was previously created. I'm also limiting it on the default namespace in this case, and I'm injecting a parameter here, a list of allowed repositories. In this case, the repository is just Rancher. So that obviously is just one policy, but in a real world, you would fill this up with all your policies, and you would have a nice central location of maintaining them and applying them to all your Kubernetes environments. So how do we do that actually? Let's have a look here. We can see that the second cluster is now registered and ready. There's one more thing that we need to do is we need to enable the OPA, the Open Policy Agent, or the gatekeeper for this cluster. I would actually also do that with GitOps, right? But just to show you how to do it here, I'll just quickly do that. So we have an OPA gatekeeper here in the catalog, and I will just install that. And once that is installed, I can start to push the policies also into that cluster. In the meantime, let's have a look how to set this up, right? Because right now I have my Git repository, but I have to configure the fleet controller to use that as a source of truth for the configuration management of the cluster. So now let's go to continuous delivery here. I can see the two clusters that I have previously just registered. Maybe I can create a group here just to show how that goes. So probably should have some labels first on the cluster. Something like maybe a label for the environment. Let's actually see what I used here. No, it's fine. Let's choose a label for the environment so that I know that all these clusters belong to my production. And now I can, based on these labels, I can now create a group. So that you see this follows what you know from Kubernetes selectors, right? So I can call this prod clusters, and I'm doing a match or a selector here, like prod. And I can even label and annotate that group also, because it's just a Kubernetes object. Now you can see I have 2 ready clusters in that group. So the next thing is to define the Git repository that should be applied to that group. I'm going to do that. So we just need the Git URL here. Oops, that was the wrong one. Let's call that OPA. And because it's a subpath, I have to also configure that. And now I can target basically where I want these policies to be rolled out across my clusters. We can do very simple matching based on by just giving it a specific cluster group, but we can also make more elaborate matching patterns based on multiple labels and so on. So you can think there's a lot of possibilities here, not just on a specific environment, but if you want to, for example, group clusters by location or by specific maintenance schedules or things like that, you can do all that as well. Just in the meantime, have a look here. So we have installed the Helm, the OPA gatekeeper is now running, so you can click that away. I want to select my prod clusters group here. And before I do that, so let's just let's just verify, that this actually enforces the policy. So I think I should have already configured this cluster here. Yeah, okay, I can see it actually here. So let's just run some image from Docker Hub. So this means I'm in the container and I can exit it, and also maybe clean up after myself. So okay, so this works, right? So I can deploy any image from Docker Hub at the moment because I haven't rolled out my policies yet. Let's change that. So we have configured the Git repository. All the parts here should be ready. I hope everything goes well. And now basically the fleet controller is now fetching the content of the Git repository, building a bundle like we learned before, which you can see here in a minute under bundles, and the fleet agents that are running on the clusters. They're going to fetch this bundle now and apply it. So you can see the bundle here. You can also inspect everything that is in the bundles. When you go back to your Git repository, you can also see basically the content of the bundles. And the ready state tells us that at this moment, this API configuration is already applied to the downstream cluster. If that wouldn't be the case, you would see something like out of sync or waiting applied or something like that. But the ready state tells us that at this moment, this policy is rolled out across the 2 clusters. Yeah, so let's verify that and just run the busybox image again. And as you can see here, hopefully I'm unable to deploy this container, and I get back a message about container has an invalid image repo, allowed repos are rancher. So now I could only deploy anything from the Rancher organization on GitHub. So obviously, I'm getting the same policy now across all clusters. In this case, it's fine because they're both sort of the same. They're both prod clusters. I probably want to have the same security policies in them. But what if I want to manage different security levels for dev, prod, test, and so on? As with everything, I want to have things reusable. I don't want to manage a separate Git repository for my dev cluster configuration. So with Fleet, that is pretty easy to implement. So I could do so basically what you do is you use YAML overlay or customize, or you could even package your policies in a Helm chart. Basically anything that allows you to parameterize your configuration. So in this case, I've just put the same constraint template and constraint YAML here, but I've also created an overlay, and I've also added a Fleet YAML. And if you look at the Fleet YAML, I'm going to make this a bit larger. We can see that we have something here called target customization. And target customization allows us to match a specific target. So in this case, I could have a cluster group called prod, and I could have a cluster group called dev, and then it maps it to an overlay. Or it could also inject different Helm values based on that. So there's different possibilities here. And if you look at the dev, it matches to this overlay. So let's have a look at the dev overlay. And you can see here the difference is I've added different repos that should be allowed. I've added my own repo and some other non-existing repo. But that should give you the idea, right? So for the development environment, maybe we want to allow more repositories so that the developers can have a nicer time on the cluster. So that's kind of the way that you customize and that you make your configuration reusable across any number of clusters. As I said in the beginning, we can also use this approach not only for Kubernetes configuration management or configuration API configuration. We could also use that to manage version of Kubernetes itself, depending on the Kubernetes distribution that we use. In our case, we are using K3s, as you can see, which is a lightweight Kubernetes distribution, but still CNCF certified. And I've currently installed it in this version, right? So I probably want to have all my clusters patched at any given time. And how do I maintain this patching? So one idea would be to use the GitOps repository for that. And define here what the desired state of your Kubernetes version is. Before I explain that, we obviously need some kind of mechanism, right, to roll out a Kubernetes patch. In my case, I'm choosing something called the system upgrade controller, which is also sort of a project from Rancher SUSE. This is a Kubernetes controller that you can deploy in a cluster, and it works on so-called plans or a plan. And a plan can be anything from starting an in-place patching of a Linux server, running something like yum update, to doing something more complicated or replacing some binaries. So basically, it can operate on the host OS level, right? So obviously, to deploy this operator, I'm doing just the same. I'm just gonna do the Git approach for that. So let me just do that quickly. I'm just adding another Git repository here. Call it operator. So this could also be the way that I could have installed the OPA controller in the beginning, right? So let's do that here, and let's make sure we get the right path. Let's controllers. And make sure everything else is okay. So in this case, I'm going to deploy that to all clusters in the workspace. Okay, so while this operator or controller is rolled out, let's have a look at how I'm doing how I'm telling this operator to keep my Kubernetes versions in line with my patch management. So here I have something called KS version. if we look at this, we can see it's a Kubernetes resource. It's kind plan, so it's a custom resource that is supported by that controller. And you can see here in the spec, I have different things. I can select the nodes to which it should be applied. And most importantly, I can select an upgrade image. So in this upgrade image, this is actually where the logic is in, right? So this contains the logic how to perform the upgrade, but that upgrade is basically orchestrated by the system upgrade controller, right? It makes sure that it's done in a rolling fashion. It also makes sure to stop the upgrade if you know, a certain number of nodes become unresponsive and all these different things. And as you can see here, I have defined a version. And basically this setup now allows me to also do you know, declared configuration of Kubernetes upgrades, because all I have to do now is I have to maintain this version string. And whenever I want to roll out a new Kubernetes version, I just do a git commit and it gets rolled out. So let's see how that would work. We are currently on the 1.19.5 version, and here we have the 1.19.7. Until now, we have not yet put the plan into action, right? So let's do that. Let's go back to our Git repos. You can see the operator is rolled out, and it should be now ready to work on our, let's call this K3S patch, and do the same thing again. Make sure that we give it the right path. Double checking. And here I will just, again, target these prod clusters and do the create. And what you can also, obviously what this also means, what's kind of nice with that also is because we get the continuous delivery of that configuration. If I'm scaling up that cluster and for some reason I'm joining nodes that run, you know, an outdated Kubernetes version, they will be automatically patched then also. So let's see what's going on here. Let's go to the clusters and the K3S. So here we are looking what's going on in cluster 01, and we see that the K3S patch is rolled out. Obviously now the patching is happening in the background, and hopefully in a few moments the patch should have happened. So yeah, that's the case. So you can see now we are running 1.19.7. This was pretty fast. That's obviously because we're using K3S here, but it could be working with any other Kubernetes distribution, given that you build the kind of upgrade procedure in a container. So that's all from my side. I think we're good with the timing, and ready to take some questions if there are any.
Absolutely. Thanks a lot, Jan. Great presentation. Very interesting stuff. I don't know if somebody in the audience would like to ask some questions. Anybody? I don't think so. I don't see any activity. So anyway, thanks a lot, Jan. It's been great to learn all of what Rancher Fleet can do. It's really interesting. Thank you so much.
Yeah, maybe just a quick point out.
Yes.
We have Academy that is completely free with labs and stuff like that to learn about these things. And obviously everything is open source. So we have a great open source community, which you can join if you go to slack.ranch.io. That's what I recommend to do. Okay, thank you.
Thank you. Thank you so much. Great presentation. Excellent. So we are pretty much ready for tonight. I'm just going to provide some last thoughts. So thanks everyone for attending. Of course, please note the dates of the next editions. They are already planned. We already have some people contacting us to present, but of course, if you have something interesting to show the community, please let us know. We have the slots available for the moment. Nothing has been decided for Thursday, June the 24th and Thursday, October the 21st. The stage is yours. This is your platform for you to show what are you're doing, what interesting things you're doing with cloud native technology, right? And to stay updated on everything that we do, please follow us on YouTube via vision.tv. Subscribe to get the notification when this very video will be uploaded tomorrow. You can follow us on Twitter, LinkedIn, Facebook, and all of these places, even in Instagram. Every so often we publish pictures as well. And Marcus is laughing. But then again, there we go.
Thanks again, Jan,
Absolutely.
and to the other speakers. Was awesome, I would say.
Thanks a lot. It's been a great session, and there was a lot of correspondence between the talks, which was pretty much unexpected because they come from completely different companies, but they all contacted us with pretty much the same concerns and the same technologies. So clearly, policies and security, it's a very hot topic in the community. Okay, so I would like to thank you all. Thanks to the speakers, thanks to the attendees. And anyway, see you soon at the next edition of the Cloud Native Computing Switzerland Meetup. Thank you so much. Bye-bye.
Bye-bye. Have a nice evening. Thank you, everyone. Thanks.
Thank you.